Hey there, this is Mr. Wilford, and I wanted to go through Chapter 6, Section 6 with you. This is our last section of this chapter, and we've been talking about a lot of different types of polynomials, and in particular parallelograms and special kinds of parallelograms. And we're going to end here with some properties of kites and trapezoids. And just to kind of go through some definitions here a little bit, just so that we're all clear and talking the same language. When we talk about a kite in geometry, a kite is a quadrilateral with exactly two pairs of congruent consecutive sides. So what we're looking at here is not opposite sides so much, but we're looking at consecutive sides, so next to each other. So as this example shows here, AB and AD are going to be congruent. Those sides are congruent. And then these consecutive sides, BC and CD, are consecutive, and they're congruent as well. And so we would have what we call a kite. There are some properties of kites. And just to go through a couple real quick here for you, 661, theorem 661. If a quadrilateral is a kite, then its diagonals are perpendicular. So we have our diagonals that we've been talking about, they would hit at 90 degrees, perpendicular. 662, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. And so here we have just these opposite angles, angle B and angle D would be congruent. A and C would not be congruent, however. So that's important to make sure that we understand that. Here is some proofs of 662. You can take a look at those. Here is an example, a problem-solving application. Feel free to take a look at that. There are several steps here. Kind of an interesting problem using the Pythagorean theorem and so on. So if you have some time, take a look at that if you can. Here is another example, and here what we're looking at is in this kite that the diagram is showing here. They're giving us some different angles, and we can use some different properties of kites to figure out some of these other angles as well. Next, I want to take a look at what we call a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So in a parallelogram, we're looking at two pairs of opposite sides being parallel. In a trapezoid, we're only talking about one pair being parallel to each other. So this is an example here of a trapezoid where we have BC parallel to AD. We have, and these would be the base sides, the ones that are parallel. The other two sides are called legs, and then we have base angles as well. So angle B and C are base angles, and A and D here are base angles as well. One special kind of trapezoid is what we call an isosceles trapezoid, and this is where the legs of the trapezoid are going to be congruent. They're going to be equal. So a couple of theorems here again as well that deal with isosceles trapezoids. First of all, 663, if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So B and C are congruent, and angle A and D are congruent. Again, keep in mind we're talking about isosceles. 664, if a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. So this right here, angle A and D, we're talking about are congruent angles. Therefore, we must have an isosceles trapezoid. 665, if a trapezoid is isosceles, if and only if the diagonals are congruent. So if we have these diagonals are congruent, then we're going to have an isosceles trapezoid. Here's an example then, a couple of examples using the properties of the isosceles trapezoid. Talking about, again, some of the angles here, so make sure you read through those examples carefully. And again, same thing here, there's some algebra work here, so make sure that you read through those. And again, if you have any questions, please let me know. Thanks.